So, a formal welcome to everyone who was honored the invitation. So, when we started last week, we said that let's do something that's called be like an active learning platform or a passive learning platform. Sorry, for most of us who are not into machine learning. But as you know, this machine learning thing is a very important skill now. It's very, very important. And the areas of application is just increasing day by day. You can apply it in virtually everything. Because everything, anything that has a physical model can have a data-driven model also, that is based on physical parameters, so to say. So uh, So to do that, we brought in people who are mainstream inclined to this machine learning thing, like Shamsuddin, Kenneth, and uh, Ibrahim Usman, Uji. So today is just for a discussion on how do we discuss a few things in the group. For example, we said that we want to meet every month, once in a month, and then we said we'll be guided by this book. Sorry, can you hear me? I want to be sure that everyone can hear me.
Yeah, I can.
Okay. So that we are going to be guided by this book, and I think everyone has agreed to it. I think there's been no objection so far with regards to the material that is going to guide us. So I just want to say that it's going to be anything, no matter how small it is, anything at all, no matter how small. Once it's something that requires consistency, then one can easily say it's going to be something that is difficult. So please, I urge you, uh, if you really want to do this thing, and maybe we have to just inculcate it into our plans. Just as we eat food, or we take our bath, we do the other things. Can just inculcate this one just once in a month.
Yeah, that
Yeah,
food is important.
come by and just share one or two things with each other. And really, the whole idea is not complex. It's just about sharing, especially led by people who are already in this machine learning thing, so that we are properly guided, and they come and just share the things they know and want it step by step. Like this book, I've gone through it. I've gone through most of the contents of the book, and as you know, it's a very stepwise thing. It's a very stepwise book. So I think that all of us are going to get one or two benefits from this. So the idea is, if we come every month and then someone picks a topic and shares something with us, even if we individually don't go through what's here, at least it has added something to our minds. Okay, this is possible, this is not possible, these are the areas that machine learning is gaining thrust in, and these are the concepts, these are the fundamental concepts. Even if you're not programming, even if you're not doing anything, even if you're not currently trying to even practice what they're doing or what we're doing now, you find that you're able to at least understand the concepts, and then uh, from there one will just uh, be armed with these skills, and then in the future, if you want to go into it, it shouldn't be a completely new thing. Just find some time, regain the thrust, uh, gain the momentum, and just you see you're just, I don't know. So it's a machine learning literacy, but it's more technical because we are going into details. We'll go through this book, and I think by the end of this book, we should be very good, at least with the concepts. So currently we have Shamsuddin. Oh, is this Madam Sham? I'm not sure if you're the one. Oh, Abdurrahman. You have changed your name.
No, I have issue with my this thing.
Oh,
My
your Tencent.
yeah. So I'm
Oh,
using
so you're using someone else.
mini app. No, I'm using mini app.
Okay, I don't know the meaning.
You know, man,
Which
fix your phone, fix your system.
So,
I'm using
yeah, I understand. Once it's time, I think let's make it a rule that we're not going to wait because no, I don't know. Once we are here and once, especially these three people, any of them, once the lead, we're going to assign a lead for every month. Once the lead is there, uh, I think we're not going to wait for people really. We're not going to wait. So, Shamu, please, can you go on? We have it's 1:30 to 2:30. That's around 1 hour. Please go on.
Okay.
Have you set up your system?
Yeah, I did.
Okay. So you want to share your screen now?
Yeah, let me check.
Yes.
just the rush, me share screen.
When you calm down now. Why you want to embarrassing no more? I think
Can you share now? Are you still seeing my screen?
wait, calm down. I'm trying to share, sorry.
Mm.
Like, okay, I can't share now. Like, it's telling me that you are someone else is still sharing.
Yes, no, you can share now. You can share now.
Okay. Yeah, can you guys see my screen?
Yeah, I can see now. You can see.
You are the one scrolling?
Yeah.
Yes, he's on screen.
Thank you.
Okay. Like, good afternoon, everyone.
Good afternoon.
Like, as Ali have already mentioned, so I think no further introduction or stuff. I think all of us we know ourselves there. So I think I'll just go on with the like
Yes.
maybe go through the pages and just discuss some stuff. Like
Okay.
and any ideas can come in, like all this stuff. It's not like all of us are still learning. So
Yeah, it's a discussion.
Roger, Kenneth,
Where's
Abdurrahman.
Roji? Let me call him. Abdurrahman, please help us call him. Yeah.
Can say I'm using WeChat. If I go
Okay,
out,
okay,
Okay,
I'll
yeah,
call him.
yeah,
I'll
yeah.
call him. I'll call him.
So I don't think we really need to go through all this stuff. So let me just start with this machine learning tsunami. Like based on this, actually, I don't know. Okay, let's talk about the history of maybe deep learning or stuff like that. According to this, but like Geoffrey Hinton, like these are the forefathers of this thing of the field. Geoffrey Hinton, them Lecona and stuff like that. So the first AI paper he published was this. He published a paper, then trained using this thing. They used MNIST datasets. MNIST datasets, they are handwritten digits for all these housing numbers. No, actually, it's not housing numbers. It's for the post post stuff, like all these letters they write and stuff like that. Post letter, they collect the data, they collect the digits there. Then they train it. They've already trained some models, but they're not deep learning models. They've gotten like really good accuracy. But with deep learning, when you train his own model, he got like 98% accuracy. And before that, people have already abandoned deep learning because they could only train one layer network. So the idea of deep learning, they thought this is not possible until they actually found a new this thing, a new a new training method. That's back propagation actually. Like you can actually train over deep layers. It got its accuracy 98%, and that's actually what brought out all these deep learning and stuff like that.
By deep
So
layers, some of us are just kids in this ML.
okay,
So
okay, I don't.
by deep layers, you just mean cascaded layers, right? Mini layers, back to
Yeah,
back, back to back,
I
back to
don't
back.
know if I can have like a pictorial representation of the deep learning system. Yeah.
Because if you use, just be careful when you use some of those terms that we don't know yet.
Okay.
Yeah.
Yeah, just okay. Let me just. Since I'm connected to the internet, let me just. So this is what we have. You can still see my screen, right?
Yeah.
Yeah, okay. In the first, oh, let me do this. Okay, this is what they could train back then. You just put your inputs, then you have a one layer, then you have your outputs. So when we have deep layers, it's actually hard to train back then until they develop this thing. When we have deep layers, when we have more than one hidden layer. Okay, no, sorry. I think I have to make this clear. In a neural network, we have two most important layers. Two most important layers. The input layer, this first one, and the output layer. These are the two most important layers. Then these hidden layers now, you can add them in as much as you want. And when you have more than one hidden layer, it becomes a deep neural network. This this structure now is just an artificial neural network because
Yeah.
it's not like we only have a single layer. This is just an artificial neural network. But when we have two or more hidden layers, this middle layer is the hidden layer. The first one is the input layer, the last one is the output layer.
Yeah.
Then the ones in the middle, they are the what hidden layers. When we have more than one hidden layer, something like this. So this first one is the input layer, then this last one can be the output layer. Output layer, when we talk about the output layer, it doesn't actually have to be one. The previous one I show, it was only one layer. It was only one node there. Okay, all these circles, they are called nodes or
Yes.
neurons.
Yeah.
So now when we talk about the input layer, they are mostly made up of what? Several numbers of these neurons or nodes. Then the output layers, it depends on your task or the task you are doing. Maybe if you are doing regression, you are doing or classification, even the classification, it can be a binary classification or multitask, stuff like that. So these output neurons, you can actually have one and more. The input layers, they are generally more than one. So these ones, when you have more than one hidden layer, all these layers in the middle between the input and output, they are called the hidden layers. And when you have more than one, we term them deep layers. So I think that's that about this thing. Sorry, I think I scrolled this more than I should. Wow, I think the general this thing here is not even close to. So I think that's that. That's that on that. So I don't think we need all this economy and stuff like that. So I think when we talk about machine learning now, let's just talk about machine learning. According as it's written on this way, we have machine learning is the science or programming of computers to tell. What machine learning basically means is like we give computers knowledge. We make we give computers knowledge. They can learn on their own and they can generalize. And when we have new data, they can actually make predictions. Simply, simply put, machine learning is just giving computers the ability to learn. And all this learning, they are actually based on all our mathematical computations, all our knowledge of this thing. Maybe matrices, linear regression, how you do gradient, and all this stuff. That's what all this stuff are. You just put everything together, make an algorithm. Algorithm, they are just like step by step implementation of step by step of ways you can actually finish a task. That's what this thing. So most of these machine learning systems, they are actually made up of algorithms. They have step by step. They have step by step implementation of all these mathematical models and stuff like that. So an example of a machine learning system, see, here we have spam filter. Spam filter, that's what they normally use in this thing. When new messages come, like when new messages enter your email, they are actually categorized into whether it's spam or not spam. If it's a spam message, then they are automatically categorized as spam and it's being kept in a spam folder. Then if it's not spam, then it goes into your like inbox and all this stuff. And this type of system, they are classifier system. They are classifier system. When you have classifier, we have like it categorizes into several categories, whether this is this. And actually this one is a binary classification system. And because why is binary is because we only have two decisions to make, whether it's spam or it's not spam. So and neural networks are generally used in doing this, but actually there are other machine learning models are used. Like we have logistic regression, we can use support vector machines and all this kind of stuff. But I think we are going to come across all these models later on in the step. So why use machine learning? The most important thing is, why do we need to use machine learning? Why do we have to give computers not this thing, ability to learn on their own? In the conventional way or the traditional way is to what? When we want to build if we want to build a system, if we want to build a system, what we do is we get our problem. This is just the pictorial representation of the approach. We get our problem, we know our problem, then we write rules. Okay, now let's say we have we want to categorize humans now into different race now. Let's say Asia, maybe Africa, America, and all these. Okay, different this thing. We want to categorize them now. What do? We write these rules. Maybe if someone is black, is going to be called is going to be categorized as what? Africa. All this stuff we write them using based on our logic, like what we can see in our like observation or like our data points. From our data points, what we can see there. That's what we actually hand code them. We hand code them. But the problem is all this. We write the rules, we evaluate it. Then if we evaluate it now, we have like some other data points we collect because in a when you're training a system, we mostly when we collect data points, we actually put data, we split the data into generally into two. We can actually split it into three when we have training, validation, we want to validate it and test it. But we generally split it into two, which is the training set and the what and the test set. So when you do the training set, you do the training set. When you when you write all these rules, you write it based on the training. Now, after developing this system now, based on all these rules you've written, now you now evaluate it on the test set. The test sets you kept aside, you won't include the test set in your listing because if you include the test set in your training data, it's going to be biased. That's why you kept it aside. Then after you've trained this, you've trained all this your rules, the algorithms you've written, you've trained it on your training set. You now evaluate it on the test set. If the performance is good enough, then you can launch it. But if it's not good, you have to go back. You analyze your error, what's wrong, what is wrong, based on what you have here, what's wrong. Then you now go back. Maybe there are some rules you've missed. Maybe there are some rules you've missed. You have to brainstorm and come with rules and other rules and all this kind of stuff again. If when you come with new rules and stuff like that, you do it again. You train that, you write your algorithm again, you evaluate it again. If the performance is good, you launch it. If it's not, so it's just an iterative process. This is what you do. And this actually time consuming and is the effort is just it requires a lot of effort. But the machine learning system, it's very, very easy to this thing. It's not this thing. What we just need to do is just to provide our data. Most generally, just provide our data. We clean it. You don't actually have to, yeah, you clean it because most of the data points we get, they are not like there are necessary preprocessing and cleaning that are required. Then after your algorithms, you set up your algorithm, then you pass in your data through the distance, then you evaluate it. It's an automatic distance. You allow the distance. The algorithms actually learn the relationship between your input and your output. When you are training a machine learning model,
Oh,
yeah,
we are just starting. What? You know what?
yeah.
Okay, so if we continue in a pace that people cannot catch up with, at the end of the day, it's going to be boring because they're not understanding, and then
Okay.
they will be forced to just stop at it. Something.
Oh,
So
Okay.
I think in other words, what you're saying is that there are generally two methods. Machine learning is now replacing the traditional approach.
Yeah.
Oh, and the
Yeah.
traditional approach is you have a problem, you study the problem, you write rules, you write rules for the problem. In other words, you just write code. You write code.
Yeah.
You write code. And then when you write code, you evaluate the code. If it's good enough, you launch it. If it's not good enough, you analyze the error. If there are bugs, you study the problem again, fix the bugs, and evaluate again. If it's okay, you launch it. If it's not okay, you analyze the bugs again, like that and like that.
Yeah.
So machine learning now is now replacing this traditional approach by saying, okay, instead of you as the subject providing the rules, okay, just give the system the data, and then the rules, what you now input, because in the traditional approach, your input is the rule, you input the rules.
You do everything.
In machine learning approach that is replacing the traditional approach, the machine gets the rules it by itself. You just give the data.
Exactly.
The machine creates a relationship between the data as the rules that you would have written in the traditional approach. So this reduces the tendency for bugs because the machine has learned the rules by itself from data you've given. So that's why this analyze error pathway is cancelled. Go, since there is less propensity
Error analysis.
for error. Yes. So I think it's clear now. Just put in mind that
Okay.
we don't know anything. Yeah.
Okay. Okay. Okay.
Yeah. Thank you.
oh
Okay.
God,
I don't.
what's next?
Yes, and please, I want to say that please, everybody should talk. Like, let's make it interactive. Just talk.
Okay,
Yeah, it's not a lecture session; it's discussion, and we are all mates here. We know ourselves. Please.
So this is just the traditional approach. Why
Are
this
we?
is the machine learning
Yes,
approach?
yes. What
Uh,
someone is
uh,
saying?
mm. No, no, just may continue. If we have question.
So
Continue.
just like Ali just said now, this is just this is the machine learning approach. We provide the data, we get our problem, we collect data, then we write a code. That's the accordion. But we don't actually have to add code it, like we don't actually have to search for if this is true. The traditional approach is you write a conditional system. If this is present in this, then do this. If this is present in this, do this. But in machine learning approach, you don't actually have to write conditional. You just give your data to the already written model. They are just general algorithms we use. You put your data to it, then it will evaluation, you evaluate it, then you launch it if it's okay. Then if it's not okay, you're still doing error analysis. The error analysis doesn't, we don't take away error analysis in machine learning system. So it just reduces me. It just reduces. We just in machine learning system, the error analysis part just reduces compared to the traditional approach.
Okay. Sorry, let me say something.
Okay.
So-
Okay, go on.
No, you can go after you.
So this process can actually be automated.
Oh,
You wanted to say something?
they wanted to say something after.
Yes,
Okay.
please go on.
Yeah,
So,
I
feel free.
wanted to before you move to this automatic thing. So I want to get the traditional method and the new method. That's the new approach. So now, if I'm correct, so please correct me.
Yes.
The traditional method, let me try and
Yes, say it in your
like
own words, what? Yes.
put it to my own words or like bring it to a practical level.
Yes.
So can I say that the traditional method, it's the writing the rules? Can I say that, for example, now I have studied my problem, so I want okay, for example, now this is my structure now. For example, this is my structure. It's
Right.
it's vibrating too much. Like the vibration is too much. So that's the problem. I want to reduce the vibration, right? So the rule now, traditionally, they will say, maybe if I'm right, the traditional method, will they say that are they is the coder or the machine, the person coding the
Yes.
code,
Yes.
is it the person that will write that if the mass is this, the vibration
Exactly.
will be reduced. If the
Yeah.
stiffness is this, the vibration will reduce.
Yeah.
Compared to
Exactly.
the new approach, whereby is it that is going to be that the approach or the method is the one that will write the rule. No, we are not, you have no concerns telling it to, whereby telling it that if the mass is this, the results should be this. If the stiffness is this, the result should be this. So
Yeah.
in
Exactly.
nutshell now, in nutshell, the traditional and the new approach, writing the rules am I responsible for writing the rule for the new approach? Like, what's the difference? Like in writing, in practice, I'm just trying to bring it to a practical level. I don't know if you get me.
Yeah,
Yeah.
it
Yeah.
depends on your
Yeah.
data now. I think it depends on your data or the kind of data you want to feed your model.
Okay.
You understand?
Okay.
So, for example,
Actually, there's that. The traditional approach, right?
Shamu.
The traditional
Yes,
approach,
Shamu.
you
Go on,
have
go
to
on.
write all the rules yourself. And in traditional approach, domain knowledge is very, very important. You have to have domain knowledge.
yeah,
Because in your own case now, like open now, you were talking about vibration now. You know what happens when this system is vibrating too much. You know maybe the frequency is too high
It's
or
too high, the
something like
amplitude.
that is too high.
Yes.
So
Yeah.
now you write a rule. If this is happening, then you do this.
You understand?
So
Shamu, sorry, Okwe.
Mm,
So now we say we do FFT now for the
yeah.
vibration. Cool?
Mm, mm,
Fast frequency transform, fast frequency transform. So, for
mm,
example, now you want to categorize your system into low vibration, high vibration, medium vibration, and high vibration. Cool?
mm,
So you have all the frequency data. So, for example, you say if the frequency is above range, cool? Categorize it. So you say if this if else statement. If the system is if the frequency, if the amplitude in this class, oh,
mm,
if the amplitude in this class is above range, categorize it as low. Else, if it is from this range to this range, categorize it as medium. Else, if so
yeah.
this is you coding, this is you giving the rules now for the
Okay.
system.
Okay.
That's why he said you have to have background, like domain knowledge of the thing. But in machine learning, you don't need to have any background knowledge of what is happening. The machine learning will know what is happening and create relationships by itself and give you the rules.
Okay.
So
yeah.
it will be the one to form the rules of, okay, if this is high, then this class. If it is low, this is this class. If it is between, then this class.
But
You
I
have to
think
business with the rules now.
what to add
Shamu, is it correct? Yes, yes, yes.
what to,
yeah, it's okay. Go on, Abraham.
Ron.
for you, Ogbe,
Mm,
since you have domain knowledge, you are the
mm,
one that will determine the futures. Like there's what they call future detection for the models.
okay.
I think maybe that is what maybe future, like
See,
we say future.
if I understand Okwe's question, go.
Mm,
It's the fundamental we want to build now.
yeah,
Yes.
Pagani
Yes.
is the fundamental we want to build now. What is in terms of rules, writing rules, what is the difference between
yeah.
the traditional approach and the machine learning approach? In the traditional approach, you write the rules.
You
If
Yeah.
do
this
everything
else, if
yourself
this
in traditional approach.
now,
You do everything yourself in
you do
traditional approach.
everything yourself. Yes.
Yeah.
But you do everything yourself and you need domain knowledge. Domain knowledge is the most important thing in traditional approach. But in machine learning approach, you don't actually have to have the domain knowledge. The domain knowledge is just an advantage when you are analyzing the error.
Okay.
And maybe you are creating features, just like Abdurrahman mentioned. Because if you have domain knowledge, you know like the stuff that are important to your problem. So maybe the data points you get, you can't actually get all the you can't get all the features you need for a particular problem. But based on the ones you've collected, you can generate new features. And that's where
You see,
domain knowledge.
Shamu, these features now will bring other questions. Because features, they are separate things again.
Yeah,
You see,
yeah, yeah.
so let's build it hankali. Now the basic is in traditional approach, you write rules. In machine learning approach, the machine learns from your data and writes the rules. Oh?
Yeah, the most important thing is the data you give.
Yes.
Yeah.
Listen.
Okay.
So if you are
Now,
working-
actually, that was what I wanted to like ask about also, because I see that maybe for me, right, the first picture of like this picture right now currently showing, right, it's almost the same with the machine learning stuff. So I kind of wondered, so what the machine learning, the introduction of machine learning does to the process, how does it make it easier? How does it make the process more effective? So, and when you guys explain about the stuff, as in the domain knowledge and stuff, yeah, I kind of understand it a little bit more.
Just see
Yeah,
from here that this train ML model that
yeah,
has input as data. Oh, can you see it?
yeah,
Let's send
yeah,
it.
yeah,
It is the
yeah,
one
yeah.
replacing. Shamu, please can you go up?
The written
It's
rule.
replacing
Is
this
the
right
one,
rule.
yeah,
Oh,
yeah,
yeah.
yeah,
That's
yeah.
that's
I've
the
understand it now.
Yes.
I've understand it now.
that's the
So,
written rule.
yeah, yeah,
And just what the machine learning this is automatically adopting the change. Then when you put it into deploy, when you build a system, you put it into deployment. Then what you just try to do is you try and automate it, because if you put system into deployment, if you deploy your system now, definitely if you build a system, users are going to use it. Then as time comes now, the data might change.
Yeah.
The data might change. But if you automate it now, the system can automatically retrain itself.
Yes, it will adjust itself. Huh?
Shamu,
Yeah, it can
please
automatically
tell us
adjust itself.
what is deployment.
Deployment is when you build a machine learning system. Let's say we build a classifier system now, like you want to, or let's say a face recognition system or something like that now. No, let's use the classifier. You want to classify fruits now. So now, if you want to classify fruits, you accept input. Your data now is an image of a fruit, maybe an image of a banana. You put it when you deploy it. You've already built the system. Now you deployment is you giving access to users to use the system.
So
So
after
now
you've trained
after
the
after you
model, you
train
have a
your
model that
model,
works now.
yeah,
So
exactly.
you want
When you
people to
deploy
use
it
it
now,
to be able to use it.
for users to use it, you
So that
deploy
is
it.
deployment.
That's deployment. So maybe
Yeah,
you go
like
to a
your phone.
website now. You go to a
Maybe your phone
website now.
phone recognition, but
Maybe you what?
your phone recognition,
Yeah,
face recognition.
yeah, face recognition. All these apps we use, they develop it. Those are those are the system. But when you download it on your phone now, you are the user now. You have access to the system. That's
You have
deployment.
deployed it to your phone, to your
Yeah,
device.
you've deployed it. So now the process of like this automation, like maybe in phone now, like maybe if you call Siri and all this kind of stuff, data might change. Example of data change is like in English now, like they add words into dictionary. But the problem is that maybe when they train the system, these words they are not there when they listen. The training data now is going to change because they are adding new words now. But if you automate it, you can actually retrain the system on the new system. Because as you are using the system, if you deploy it as you are using the system, the data are being collected. No, not all this thing, not all system actually are collected, because the issue of privacy is another thing entirely we still discuss.
Yeah.
So that like the recent points you just made, that's what I wanted to ask. Like automating the process.
You automate the
So
process.
yeah, like where data, like whereby there are some data that are not available, like generally like available to the public. So that's what I wanted to ask, but you just said the issue of privacy. So maybe it might restrict the automation. You said?
Yeah.
Yeah.
So like the automation, if I and Shamu, correct me if I'm not understanding correctly. So it's like initially when you were training the initial model,
Yes.
you are the one that give the system data.
Mm.
You already know this data,
Mm.
and the data is already known and is fixed.
Yes.
Is predetermined. So this is the because it has a beginning and it has an end. The data you are given.
Mm.
Oh, so you give
Yeah.
this model data, it trains,
Mhm.
and then you deploy. But for example, the area of deployment,
Mhm.
in the area of deployment, the model is exposed to seeing
Yeah.
new data.
Yes.
So for it to give accurate prediction, it has to be able to learn from those new data, from this new data. So automation is you allow it to receive this data, train itself automatically, and give results.
Yeah.
Mm.
It gets better with all
No,
data you put.
in addition to the data you've given before.
Yeah.
So it just adds to it and retrains the model.
Yeah, it has to the
That's
data, then retrain the model. Though there are actually various ways to do that, but I think
Mm.
it's out of scope for now. So, but some people actually this automation is not like every system you use. Some people actually train it manually. Maybe after 6 months, they collect the available data now, then they add it to their system, then they retrain it themselves. But there are systems you can automate. Maybe recommender systems, stuff like that. Recommender systems are all these, like maybe all these Netflix. If you watch maybe movies on Netflix, based on what others have watched, then they can recommend movies to you. Or maybe if you buy products on Amazon or stuff like that, if you buy maybe shoe now, like they can check the data of what people that are buying shoes to the stuff they also buy. Maybe they buy shirts too, they can recommend it to you. That's what a recommender system is. Those kind of systems they can actually automate them and stuff like that. So deep learning, machine learning can be so machine learning can help us learn. That's just the most. So and the more data you have in a machine learning this thing, the better the model. Though actually there are generally two classes for this thing. AI generally is making computers learn, but this machine learning and deep learning they are kind of two different approaches. Machine learning, like machine deep learning, they are only based on this artificial neural network. Deep learning, this is what deep learning, neural network and deep learning, this is what they are this thing. But when we talk about machine learning, you have like others several this thing
What is
algorithms like we have support vector machine, something like support vector machine. I don't think you don't actually have to know the full this thing, but there are several different. There is support vector machine. There is the likes of them, maybe logistic regression. I think maybe we all know logistic regression,
Mhm.
decision tree and stuff like that. Those are categorized as machine learning algorithms. But deep learning, they are just what? They are just neural networks. And all this, they can have like they have different things. We have convolutional neural. They have different types of this thing. The neural network is not just this particular type of stuff. There are different different. We have recurrent neural network too. I don't think we have all this stuff yet. But I don't think that one is necessary for now. Then as time goes on, I think we are going to come across all those systems. So like generally, one type of neural network is what CNN, convolutional neural network. And this convolutional neural network, they are mostly used for images because they've shown like very good performance on image data, on images. So the convolutional neural network, they are just a class of neural networks used for what? Mostly used for images. You can use them for other stuff like that, even for audio and all this stuff. You can use them, but their performance, the best performance is when you use them with images, stuff like that. So this detecting tumors in brain scans, like this one is just an example of this thing. Okay, the first example, analyzing of images product on production line or automatic classify them. Like production line now, you can just automatic classification of this. You can just on production line, your products can come, then you can actually tell this is this is this is this. You can automatically categorize them. Then detecting tumors in brain scans, like in hospitals, they have all these scans. If you collect scans, they train a model like this CNN model. Then it automatically detects whether it's what this is a tumor, this is a malignant tumor or a benign one. Whether this is a deadly tumor or it's not deadly. That's what this detecting tumors in brain scans automatically classify new articles. Like some new articles, if you go to a site now, they can collect this thing. This one, they are new articles, if you get an article now, or example of all these articles we read now, if you get an article now, you can pass it through the system. The system will tell you which category, you can categorize it. Okay, this belongs to maybe different categories, like maybe vibration, this thing. You have different topics you want to classify them in. If you collect the articles, you feed into the network, into the system, it's going to tell you, okay, this belongs to vibration, then this to maybe astronomy, this belongs to maybe different categories actually. Maybe sports, maybe this article it belongs to maybe politics. Automatically classifying now article, this what this, and they are generally what natural language processing. All these models that deal with text, they are referred to as natural language processing. That you have to what your input data, they are text. They are the word natural language processing, and this has actually been making wave this thing. Now, like the likes of them, Chat GPT, they are language models, stuff like that. So we actually have other this thing, like there is recurrent neural network. The recurrent neural network, we mostly use this one for time series data. Like the likes of them stock market, we use recurrent neural network in predicting them. So I think like the main categories of neural network we've mentioned, we have CNN now. These CNN, they are generally used for images. We have NLP. This NLP, they are normally used for, they are generally used for text data. The RNN, they are used for what? They are used for what? Time series data. Like maybe the likes of stock, we can use this RNN too. We can use them for text data, because like in English now, let's say we want to do like maybe translation sequence. They are our data. They are just sequences of text. So what follows if I say now the board is black now? What this sequence of words, they have meaning attached to them. Like they are very important. Each part of them, they are very important. So I cannot say black now. If I just say board now, you won't know what comes after it. But if the inputs or the data or the text that follows or that comes before it, they are very important. Then you can actually use all these recurrent neural networks for them.
So, will you use recurrent neural network, for example, if you are dealing with frequency?
With frequency, I don't know, like which kind of frequency, like which particular difference?
I don't know, like frequency data.
Frequency data, I think it should be it should be able to use it, because maybe the last of them, maybe audio recording and stuff. They are audio
Yeah.
recordings and stuff. You use the recording neural network.
Yeah,
I think his question,
there is a strong
about numerical
relationship
data.
between.
What?
You said?
Gunji, are you talking about numerical data? Whether you can apply RNN for numerical data?
No, not numerical data.
Okay.
More like frequency. I think there's a way they used to collect frequency, right?
Yeah, like there is, since I really think like since there is strong relationship between the time
and frequency
domain and frequency domain. So it's almost the same thing. Saying you are supposed to use RNN for frequency domain stuffs.
Yeah. We they use it for frequency detection, because even audio self, all these language models and RNN, they perform well with audio data and text. And text, actually, all this NLP that I was talking about, you use text data. It's not like we actually use the text data raw like that. We have to convert them into numerical values before we pass them into the system.
Definitely, you have to find a way to map it, right?
Yeah, you have to map all these text into numerical values. Then before you run it through, because the system can only take numerical values, you cannot pass text to it. And the process of converting it to numerical value, that's another thing entirely.
That's where your
like
code
embedding system.
Like your code this.
Okay, like since we are talking about all these applications and stuff, like types of neural network, I think I can't help but notice these transformers. So I saw somewhere, right, that
Yeah.
this transformers technology is what really made something like ChatGPT possible right now, right? Yeah,
Yes.
this transformer stuff. So is it also one of these NLP or RNN neural networks, or it's a different kind of neural network in
It's
itself?
NLP.
Yeah.
It's NLP.
Or
NLP.
it's an NLP?
Yeah, because if you see this thing, they normally term them as LLM, large language models.
Okay. Okay. Oh,
Large language models.
LLP, large language models. Oh, that's
Yeah,
what the
that,
transformers are.
but yeah, actually the
Mm.
basic this thing neural network they use, they are still RNNs actually. NLP is just like the general task of dealing with text. That's what NLP is. Natural language. That's what natural language. Anytime
Yeah.
you have to deal with doing with language, all this text and stuff, that's is generally called natural language processing. The RNN, they are just the models they use in doing in building
The
an
natural.
NLP system.
Okay. Okay. So how
So
about the transformers are kind of RNN, right?
yeah, they are kind of
Oh,
RNN. We have RNN, LSTM, and so they are recurrent neural network. Let's just leave it at that. Then we have another application, automatic plugging of offensive comments on discussion forum. Like in Twitter, on Twitter now, they use all this kind of stuff now. Maybe if you make offensive this thing now, they might block you. Like the issue of Buhari and stuff like that, they are report. Okay, I think maybe the issue of Buhari and stuff that time. I think maybe their system didn't actually flag it as offensive and all this stuff or stuff. It's people that reported and that got this thing. But generally, actually, there are some platforms that if you post a bad comment, it won't even listen.
I think it's
The
Twitch or this place that they used to play game.
Twitch,
okay,
I think. Twitch,
okay,
I think.
Twitch,
I don't know.
yeah,
Mm.
Yeah,
Twitch.
in their chatting something. They
okay,
used to put chat bot that used to chat police or something. I don't know what they call it. But if you
okay.
say
They are
something,
monitor the
it's like,
listening. Hello?
wait, nobody's hearing me.
Yeah, I can hear you. I can hear you. So I was just saying, like, okay, there are some like I think maybe I don't know, maybe Facebook actually. If I think there are some platforms that if you post an offensive comment, your this thing you won't be able to post it.
Mm,
You will send it, but at the end of the day, it won't appear.
yeah, I think even in YouTube, they used to censor comments that you cannot send.
Yeah, you are right on Facebook. Like some maybe bloody like content that contains blood. Those ones are picture based, sha. So they usually restrict it from viewers.
Yeah, something like that. They
Mm.
use something like that. Then there is summarizing long documents. You can actually bring in maybe your article, then you can feed into it. It's going to create a summary of the entire stuff for you. It's going to like instead of you having like 1,500, you just can shorten the entire document into maybe 500 words. It's going to create a summary. Then creating a chatbot or a person. I think all of us know what a chatbot is. We've done it and stuff like that. Like maybe if you buy something on Pindodo on this thing, maybe Pindodo now, you message this thing. They normally have their chatbot. Though their chatbot is kind of actually useless actually. I
Yeah,
think
but
if you
like
message them, they only
if you are watching streams, if you used to watch streams, usually streams they used to have chatbot.
okay. Yeah. So we have chatbot and like personal assistant, maybe all these vendors, if you chat them up, most of the time they are not available. But if they have the chatbot are actually chat with you and those things. Forecasting of companies' revenue, this one is actually time series and stuff. Their RNNs are usually used there and LSTM and
Oh,
GL. Yes.
you need to find somewhere to. We are stopping around 10 minutes.
Okay.
Yeah, so that we'll discuss more on like so that we'll have some just in some 10 minutes, just find a good place and then
Okay.
we'll discuss. Yeah.
Okay, this is this thing, another application. Making your app react to voice command. This is what like the likes of them Siri, where you say a Siri and all this kind of stuff. Siri, a Google and all this kind of stuff. You can use them here. This is another application. Detecting card fraud. Now let's say this is also used. Like maybe you register your this thing, you are a Nigerian and all this kind of stuff. Then the you want to access this thing. Maybe you want to make purchase now, and you are using your card details are being used in, let's say, US now, it can flag it as this thing. They will have to send you message to verify and all this all over. This is being used in this thing. Segmenting clients based on their purchases so that you can. This one is actually based on clustering. When we buy goods in supermarkets, then you can buy goods in supermarkets. Then based on what you buy now, they can segment the different. You can make like different segmentation. Like maybe these are the people. Like they can categorize people. These are the rich clients. These are the like the average clients. These are the this thing. So they know what to offer each particular segment of this thing customers. And it's a very good thing. You can learn this thing. Then complex high dimensional data in a clear and insightful design. This one is actually dimensionality reduction. And this one actually you have, let's say you collect data points now. You can have like data now. You can have, okay, I don't want to talk about features now. Okay, let's talk about features are actually the inputs you put into the data. Let's say the features now. If we take human as an example now, a feature is your height, a feature is your age, your color, your body, your this thing, your complexion is your feature. It's another feature. So now, if I want to, maybe let's say now we want to categorize someone now into maybe an Asian, an African, or so. These are the kind of features we can collect from this now. So if I take Abraham now, okay, Abraham now, this is, I will just select some features I want to collect now. I will ask Abraham, what's your, okay, no, age is not actually a good thing to have if you want to categorize someone. Age doesn't tell you much. But age can be a feature. Age can be a feature. His body, this thing, his complexion can be a feature. His hair color can be a feature I use. These are what we call features. And all this stuff, at times you can collect as many as thousands of all these features. But the problem is that when you have too much features, it can be very hard for the system to bring insightful this thing, to learn something tangible from all these features. It's going to learn, but the performance cannot be as great as if you reduce it. Let's say out of 1,000, you can then reduce it, suppress it to, let's say, 20 features. If you suppress it to like 20 features now, the system can learn better and you can even do visualization from it. Like generally, what the visualization we mostly do, they are maybe I think the highest is we go three-dimensional this thing, the three-dimensional. When you go to the higher dimensional, it's very hard to visualize them. So you can just compress, let's say 10-dimensional data, you can compress it to like three-dimensional this thing. Then you can, so that you can view it. Okay, this is this. And important application here is this thing. Important this thing is Cisnet. There's one package called Cisnet. You can use it to make visualization, stuff like that. This one is a recommender system and all. Build an intelligent bot for game. There are like all these games. You can build bot for games. This one is actually reinforcement learning. Like you can build a system that can actually play game, automatically play game. That no matter how good you are, I don't think you could be able to beat that particular thing. That's that. So I don't know, maybe this is a good spot to
So
just talk about the type of machine learning we
the
have here.
reinforcement learning, is it part of machine learning? Like, is it under machine learning?
Reinforcement learning. Okay, actually, all this, well, yeah, it's part. It's part. We generally have three tasks in machine learning. We have the supervised learning. Supervised learning, you have your input, then you have your output predetermined.
Yeah.
But in example is, let's say if you want to classify an object now into like regression or classification, those are examples of this thing. If you want to classify a cat now, you have an image of a cat, that's your input. Then you have something, you have your label as cat. This image, this is a cat. This image, this is a dog. Those are supervised learning. You have your input and you have your output. We have unsupervised learning. In unsupervised learning, what you have is just the input. You don't have the output. Example is that of segmentation. The segmenting clients here. We talk about this clustering. You only have your input data. You know what people buy. Those are your input data. You know what people buy. But now your system now will determine, okay, there are three sets of people here: the rich, the average, and the low income earners, and all this stuff. Your system will just take the input, then produce the output for you, but you don't actually have, you won't actually have to specify your output when you are training, when you are feeding the system with your reason.
Yeah.
What you only have is the input data. Then in reinforcement learning actually kind of fall in both categories. You train a system, and when you are training a system, when the system performs good,
You
you
reward it.
reward it. Then if it performs bad, you punish it. How do you reward it? Let's say if you are keeping like maybe a particular score now, whenever this thing make a good this thing now, you add +1. If it performs bad, you can maybe subtract, maybe like minus 0.5. That's how you train reinforcement learning. And those are what they mostly use in all these robots, parts planning, all this robot stuff. Yeah. That's what they actually reinforcement, and that's what they generally use in building them. So that at the end of the day, if you train a robot system, you can actually have it moving on this thing. You don't actually have to provide guidance. It can actually, based on what it has learned, it can move in this thing in its own path. I think that's what all this type of machine learning system now. This is what I believe this is what it is. The supervised learning, the unsupervised learning, and actually the supervised learning. We've talked about it. Like you have your inputs and you have your output. In unsupervised learning, you only have input. You don't actually have to. You don't have output. In semi-supervised learning, there are some data points that you have inputs and outputs to, and there are some data points you don't have outputs to. That's what semi-supervised learning is. Self-supervised learning. Yeah, self-supervised. I don't know. Okay, actually, I don't know. I don't know about self-supervised learning. I don't know about self-supervised learning.
Maybe it's like when you deploy.
No,
Okay,
no
maybe
worry, we go research am.
When
maybe
you
you
deploy,
automate
Come
it.
back next
when you
week.
deploy, it will start learning by itself.
Yeah, maybe it's like if you build it, then you automate it, then you start learning on its own. I think maybe that's self-supervised learning.
All right, guys. I hope you enjoyed the session. So now, based on what we've done so far, so do you think, because our first proposal, yes,
Small chops.
now?
No small
You're,
chops.
you are fasting.
Okay, so the so far the initial proposal was every month, and then we also need to consider, so that means we have to consider the frequency. Then we need to consider the time. How much time should we dedicate to this? I think basically these are the two things that we need to talk about now. Any suggestions, please? So do you think per month or by monthly, like every 2 weeks?
Okay, I feel like, but I think month is so long for this
It's
thing.
too
Because
long, huh?
if
Yeah, me
you
too. I
come
felt so
after
when after you finish this.
if
I
you
felt
come after a month now, you might have
you
even
forget.
forgotten this
Yes,
stuff
yes, yes,
we've talked
yes,
about.
yes,
Unless maybe you revise it and go over this stuff like
yes,
that. But
yes. I agree with you. I agree with you. How about others? How about
I feel like
others?
maybe 2
2
weeks
weeks.
is okay. 2 weeks is okay.
Every 2 weeks, oh? Every 2 weeks.
Or
Unless you
every
can have
week.
like
Or every week.
Guy, yeah, wait.
I'm going to speak for yourself. Speak for yourself.
Speak for yourself. Don't speak for me.
I speak for you.
Every
See
2 weeks,
this guy.
it will quickly be boring, oh? It will quickly
No,
become boring.
every week mine is okay.
Every week, 1 hour,
yeah,
like
every week
this,
Yeah,
now.
1
like
hour
this
I
one,
think is
like
okay
this.
every week.
Every
1
week now is
hour.
okay.
Yeah, I think
Every week,
it's
1 hour,
okay.
like this,
Even
no?
the 2 weeks, they sound very long. I hope
Yeah,
we
the
can
2 weeks
keep up,
now.
Sha.
Yeah, the 2
I've
weeks
not.
Yeah,
now.
the
I don't
thing,
have Rashid
hello,
Magana
can
or
you
Tito
can you
Umar.
can
Or
you
Rashid,
But I think the main thing is consistency. Consistency
yeah,
above it. Okay.
Yeah, that's what matters.
yeah,
Can we be consistent weekly? That's the
the 2
question.
weeks, 2 weeks, what?
yeah, that's good.
It's 2 weeks.
2 weeks
It's
is
okay.
okay. Okay,
So
what's
what? 2
your
weeks is
Because
reason?
good.
we are
What's your
not
reason?
we are not
Let's
going
adopt 2 weeks. Let's adopt 2 weeks,
to
guys.
2 weeks weekly.
Now,
Guys,
We were many share that to 2 weeks.
eh,
But
2
we are
weeks,
not
huh?
that many.
Okay, 2
After
weeks.
every 2 weeks. So what? How much time are we going to allocate to it? Is 1 hour enough? I think it's not enough. My own opinion, there.
Or maybe we should extend it to 3. If okay, I
Now,
don't know, Charles. Maybe we can just extend it to 3. Maybe 130 to 3 also.
1:30 to 3. Go. Okay.
Maybe
Any other suggestion? 1:30 to 3. That's 1 hour 30 minutes.
like I'm not hearing from the other guys,
Who
Charlie
is your
and
They're
Roji.
all they're all listening. Abdurrashid said 2 weeks is okay.
Okay. Yeah.
So 1:30 to 3. Who?
Abdurrashid ya magana ne?
Yeah, magana naji. Who? Abdurrashid.
Uga san da kai maganan Twitch baka ji na saka ba.
WeChat ina ne? Ka hakuri, WeChat ina ne bai ɗaukar mutane.
Okay, so every 2 weeks, 1:30 to 3. Who? 1:30 to 3. Is it okay by everybody? 1 hour. That's 1 hour 30 minutes per week. By monthly, 2 times in a week.
It's okay.
Now?
It's okay.
It's okay. So there's no
It's okay.
objection. No. I think that's all. But now, as we go in, Shamo, I think sometimes we'll just this. Do you use this Google Colab?
Collab?
Yes, Colab.
Yeah, I use collab.
So that because sometimes we need to really run these codes and see, huh?
Okay, no problem.
So at those times, maybe it will take more times. Yeah.
No, I don't. It's not really this thing. I can actually maybe the person that's actually
can write it
listening
before.
can actually
Okay,
set
yeah,
it up
do it before,
the
what? Yes.
Then you just
Just
go
run.
through the and
Yeah.
run it.
So the 1 hour 30 minutes is okay in all cases. Okay in all cases. Cool.
Yeah, I think that's fine.
I think that's all for today. Thanks, guys. That's all.
Let me give you back your screen.
No, I'm done. I'm not sharing anything actually. There's nothing to share. Does anybody want to say anything?
Now you want to touch screen.
Does anybody want to say anything? I think we enjoyed this session. Yeah, I enjoyed this. Yeah. I
Yeah,
think
it's good.
Yeah, it's great. It was great,
Very good.
actually.
I think it's
Yeah,
really good for us to have all
Something
the
like this.
basic knowledge of all
Yes,
even if you are not actually inclined, you not
Yes.
that deep into the
I
field.
could have a general idea. Yes.
Yeah, I have the general idea so that maybe if you attend maybe conferences and all of this
You
stuff,
understand what they're
you
saying?
actually understand what the people are actually saying.
I agree with you.
Yeah. That's it.
Bye now, guys. Enjoy the rest of your day.
So you guys